All right, so I got my introduction to Raico. First, before we dive into all the system intricacies and so forth, feel free to introduce yourself to the audience and where you focus on the Pacific Northwest.
Yes, we do. We represent Raico, and we are a glazing contractor based in British Columbia, and we do jobs all over North America, but mainly in the Pacific Northwest is our focus. And typically high performance, so passive house and the like, or specific materiality like timber back sections, steel back sections, freeform skylights, and types of applications that where air and water and shapes become challenging. And so this is what we're focusing on with our fabrication company, Blackcomb Facade Technology.
So the super interesting part is I have a background with Schuko systems and understanding the means and methodology of fabricating and assembling European-style fenestration systems. And it's obviously very different than what we see here domestically or in the USA, or sort of the way these systems have evolved over time. Before we get into that, like sort of third tier of fabrication that you were describing, what do you think was the original evolution of why the way European and domestic or North American systems sort of went two different directions or paths in the way they thought about means of, as you said, drainage, air tightness, gasket joinery, how you manage air, water, thermal continuity, and so forth?
I think a lot of it has to do with the way Northern Europe thinks about the environment, and you know, these companies are as old or older than most of the North American big system houses. But that being said, like the Passive House Institute started in the 80s or 90s, and then in Germany. And so that type of influence in terms of air and water management, thermal performance, made them evolve. And so because they cared about the environment, because energy in Europe is really expensive, because they wanted to reduce their footprint, they went to this application which mitigates the impact or demand on energy for single family homes and commercial buildings. So they've been thinking in such ways for much longer than North America. And in our experience, we've been working with European systems for 10 years, mostly driven by, we sought them out for reasons of quality first. There's also a culture where they care a little bit more about the finishes and about everything that has to do with just handling of material. Like we would get scratched up and dinged material from North America, and from Europe, it comes half a world away, and everything's in sleeves and well protected, and everything's perfect the first time. So there's that the start. But second, the building codes in BC evolved really quickly over the last 10 years and still evolving. But by 2032, all buildings in BC, in terms of compliance with energy performance, will have to be, it's not necessarily a passive house building, but it's a passive house-like building. So thermal performance and air tightness will be at that level. Let's use passive house as a reference, because it's, for all intents and purposes, it's a good recipe to build an efficient building, if you will, right?
So last month we had Boston, and it's a similar model in that with the new Massachusetts stretch code, they're building, as you said, to the passive house standard level. So are you finding more and more teams opt to go with passive house compliance because they're already at that baseline?
Essentially, so for us, the demand, at least from our local market in British Columbia, it is sort of mandated, and we've developed this niche. Especially, it started more in residential, and now it's creeping into the commercial. Like the city of Vancouver itself has mandated that all of their buildings that they own, like fire halls and community centers and the like, would be passive house certified. So now we're on building 4 or 5 of those typologies. We're not creating this demand, it's the other way around. So we've developed this expertise, and then the phone rings because of that expertise. And so, but it's very rarely a choice, an environmentally driven choice to build a passive house. There's some homeowners that would make that choice, but that's not what we're seeing. We're seeing this is code driven, very code driven, or mandated by a government body like the city of Vancouver.
When you're working in a market, part of the discussion earlier in the podcast was people electing to build to baseline code and not electing to go above and beyond unless there's some other extremity or driving factor. And so British Columbia is an extremity, at least in North America, in terms of this standard. So when some of the projects you were showing me where you're building to incredible sizes or spans and spanning multi-story and with units under load, how are you mitigating or combating all of that gasket joinery we were talking about to still achieve the air tightness requirements? All of a sudden, are the units under much more pressure, and are all those interface conditions stressed that much more?
No, not necessarily. The biggest challenge for these really big spans and with high loads, especially when we're talking about Raico steel system, which can take much bigger loads for glass weight and for wind load, for deflection. It's when we bring in the seismic racking consideration, and that code has evolved over the last maybe 2-3 years, where it's the amount of movement within the stick build system is quite high. So that's another new challenge that we face, that we figure out, but it's job by job. We've got to adapt a little bit. So that's been the challenge. But the joinery and the gaskets, the Raico system is pretty bomb-proof the way it's applied. The gasket's really robust, and instead of being spline gasket, I mean, I'll urge your listeners to go and look at Raico and their catalog, but it's essentially this continuous gasket over the whole plane of the glazing pocket that when it's locked in with pressure, it's bomb-proof. So.
And how is it connected at the corners?
It's dry glazed in the vertical plane, and then in a skylight application, it does receive some injection of sealant, but only in the glazing pocket, not behind the gasket into the warm space or the back section. Yeah.
So for me, for a very long time, it was sort of unconventional to do designs like this in a dry glazed application. Mm-hmm. All I really knew was wet sealing, mm-hmm. Especially coming from the unitized curtain wall side of things. If that's all you've known, or if that's what you're accustomed to, do you look at me as if I'm crazy for even asking that question?
No, not at all, because the first time I saw, like 10 years ago, the first time I saw the Raico system, I thought there was something wrong with it, not the other way around. And on our team, we have some older glazers and everybody's reaction, like, what is this? And how does it it's so strange. But then once you start looking under the hood and getting a bit of more traction and experience with it, then you can see like how powerful it is in terms of it taking the architectural intent, whatever that is, and adapting it, and not having to design a bespoke application that requires a ton of SSG applied in the field. So yeah, it's hard to say in words, but that's it in a nutshell. Yeah.
How have project teams, in terms of facade consultants and designers, received it? And if it is sort of a system fabrication methodology they're not comfortable with, are a lot of performance mock-ups required? Do you have to sort of prove compliance through testing in the fabrication shop?
So Raico's systems are ASTM tested, so that's the certificates are there to prove out the system. I would say that most envelope consultants that we know are well attuned, and so the North American consultants, I'll rattle off a few, like Stantec, Morrison Hirschfield, and RDH, and Richard Green, who's here promoting his new book. Like they all received this with open arms when we presented our wares to them, because they right away they saw this gap in the products of limitations. They've seen enough PMU tests fail.
They like the idea of triple weather stripping. They do,
and as opposed to compartmentalizing the glass, that the continuous gutter drainage, which is essentially, it's a skylight system that we're putting in a vertical facade. Sure. So the water shedding piece is pretty strong, and everything being positively lapped. It's once you see it go up, you realize, oh yeah, that makes so much sense.
In your eyes, it's just a very performance driven product.
Totally, and it's different strokes for different folks. In terms of price, like the aluminum sticks they're very similar in price than what we can get in North America. So it's not like it's pushing those boundaries. Where we're getting a bit more resistance on the price side is the doors and operable vents. You look at what they are compared to a commercial door, North American door, they're not the same, and so that you can see that there's value in why it's double, sometimes triple the price, but. That's a discussion for another day. Like if the nuts and bolts of this is the curtain wall and skylights and the interesting things we can do with the different materiality, right? So,
on a finishing note, what's your favorite project, or a project that you think is the best demonstration for people to look up or look at to get a sense of capabilities?
One that we did recently is the University of British Columbia, the Museum of Anthropology. It was an Arthur Erickson building built in the 70s and needed a reno. The acrylic skylights, curved acrylic skylights, there's about 12,000 square feet of them, needed to be replaced. And so we replaced them with Raico steel system. The project worked beautifully, and the scrutiny with the testing, PMUs, the seismic racking we did on the PMUs, the site testing, there was 4 B7 tests done on site on these skylights, all passed. And so aesthetically, performance-wise, it's a really beautiful building. And then the other building that I would say is a crazy reference is called, I'll pronounce it in French, it's called La Scène Musicale. So it's a music venue in Paris across from the Eiffel Tower. It's a ball shape. So it's a mass timber grid shell with the Raico system applied to that mass timber grid shell, and it's huge, and it's absolutely beautiful. And then the probably the epitome of like an integrated design, directly applying the glazing system to the primary structure and using the least amount of components to achieve this facade, right? So direct to the structure is the lowest footprint in terms of us as glazers not adding more than we need to a job. So
yeah, absolutely. We'll be sure to share those projects here and put them up on the screen. And thanks, JF, for coming on.
Yeah, thank you. Pleasure.